So this video is going to be about the second kind of reaction, which is decomposition reactions. So decomposition reactions are when you have a compound and it's breaking down into an element and another element. You will notice that this reaction is actually exactly the opposite of formation. So let's say we had the formation reaction for sodium sulfide. That means that we would have had Na plus S8. Remember that this is that diatomic list that we have to memorize. So even on your periodic table of elements, you should write H2, N2, F2, O2, Cl2, Br2, P4, and S8. Again, diatomic list, you must memorize this list. So this is sodium, this is sulfur, and it's going to make sodium sulfide. So that is Na, and if I look at my table of ions, I see that Na is positive, sulfur is 2 negative, so the 2 goes down here. So I get Na2S is the formula. Okay, if you are not getting this yet, so not seeing that Na positive and 2 negative gives you this as the formula, then I would go back to the video on ionic bonding, and I would probably do the whole video on ionic bonding and just look up examples of ionic bonding, or I have another booklet if you want another booklet of ionic bonding. There's one on Canvas too that says Chem 20 review lots here. That is lots of examples in there of this kind of like coming up with the formula from the name or going back from the name to, or sorry, from the formula to the name. You need to practice that, because if you can't come up with this formula, that makes it pretty tough. Okay, now we're going to balance, so it's Na and S and Na and S. You notice that this has a 2 here, so this is got 2 sodiums, 1 sulfur. This has 1 sodium and 8 sulfurs. So we need it to get to be the same. So I would probably start with the sulfur because this needs to be 8. That means I'm going to put an 8 in front of here. The only thing that you can change is coefficients. So you cannot add subscripts just wherever you want. The subscripts come from the balancing of putting the two things together. So the subscripts come from either being diatomic, or they come from it being like Na positive and S2 negative. The 2 here comes from that, right? You can't add subscripts in the middle of it. Okay, so 8 Na2S. So now we're going to put in an 8. So now what we're going to do is, I see that there is 16 sulfurs over, or sodiums over here, sorry, and 8 sulfurs over here. So this matches, but this doesn't match, right? I have 16. So in order to get that, I need to put 16 here. So now I just want to talk about the opposite. So this video was supposed to be on decomp, right? This reaction here is not a decomposition reaction. This reaction is a formation reaction. But if I take this reaction and do this, and put in the same balancing, now this reaction has become decomposition. Because this is a compound, this is an element, and this is another element. Okay, let's try some more. So we should try at least 4 or 5 more on here. Okay, so we have P2O5, and it's just like that, and it says write out the rest of the reaction. As soon as I see that this is a compound here, and there's nothing else written there, that means that this is a decomposition reaction. So this is going to decompose into phosphorus and oxygen. But remember that list. Right? So P actually happens in 4, so there should be a 4 here. O's happen in 2, so they like to happen in 2s, and that's only when they're elements, right? So this is an element, and this is an element. I want you to write out the name of this, write out the name of this, write out the name of this, and balance it. So if you're practicing along with this, I want you to pause the video and write it out. So the name of this one, this is a covalent compound. That means it has 2 nonmetals in it, is diphosphorus pentaoxide. This is just phosphorus, and this is oxygen. Remember that these are the reactants, and these are the products. Okay, and balancing. So you might have to write out your list like this. And if I count over here, I have 2 phosphoruses on this side, on the reactant side. I have 5 oxygens over here. On this side, I have 4 phosphoruses and 2 oxygens. So I'll start there. Okay, now if I want to start by balancing the phosphorus, I see that this has 2 and this one has 4. So in order to get the 4, I'm going to put a 2 in front of the compound, so as a coefficient. That is the only number that I can change. I can't add subscripts or superscripts or anything like that. I can only add a coefficient. So now I have a 4, but this also changed the oxygen. So now I have 10 oxygens. So now I have 10 oxygens, okay? And over here, this works out, right? That's okay. But this oxygen, I need it to be 10. So the only number that I can put in front of here would be a 5, right? To make the 10 that's there. So now it is balanced. Okay, let's try another one. Okay, so this one also comes right directly from the worksheet. So this is aluminum sulfide decomposes. I can tell it's decomposing because this is a compound and there's nothing else reacting with it, so it's not like switching dance partners or anything like that. So it has to be decomposing into its two elements. So you might want to pause it here and see how far you get with it first. Okay, I want you to write out the element and the other element it decomposes into. Write out the name of this thing. So for instance, this is aluminum sulfide. It decomposes into aluminum and sulfur. Did you get that the sulfur has an 8 on it? Again, from the diatomic list. So you have to memorize this list. It's super important. As soon as you come into the test, that should be one of the first things that you write down. So this has an 8 here, and this has a 3 here. So if I'm counting, this has 2, this has 3. Over here I have 1 aluminum on the product side, and I have 8 sulfurs on the product side. To get it up to balance, I have to know that couple things is if I just start with the aluminum, and let's do that just so that you can see what happens if I start with something that might not be the greatest. If I start with aluminum, say this one has 2 and I need 2, here I put a 2 there. That's okay so far. But then I see that sulfur has this 3 and 8. So I have to come up with the lowest common multiple of these two numbers. So the lowest common multiple would actually be like multiplying the numbers together. So 3 times 8 gives me 24. So that's the lowest number I can get them to be in common. So that means that to get 24, I have to multiply this one by 3, right? Because 3 times 8 gives me the 24. And I have to multiply this one by 8, because 8 times 3 gives me the 24. And this 8 times 2 gives me the 16 now, so it changed the aluminum. So I'm going to have to do that same thing over here. So I'm going to have to do 16 in front of here to get it to balance out. Okay, let's try another one. So FeCl3 decomposes. So you need to decompose it into iron and chlorine. Do I write chlorine just like this? The answer is no, it is a diatomic, so it should have a 2 here. Okay, is iron a diatomic? No, it is not. So there should not be a 2 here. So make sure that you don't have that, right? There also should not be a charge on it, so you shouldn't see like 3 positive or 2 positive or anything positive on there, because it's an element. It can't be combined with anything else, so there shouldn't be any charge on it. Okay, make your list underneath. FeCl, FeCl. If I count how many irons are here, there's 1. If I count how many chlorines are here, there's 3. If I count how many irons are here, there's 1. If I count how many chlorines there's 2. Okay, now we need them to be the same. So to get these two to be the same, I'm going to go, okay, 2 times 3 is 6. So I need them both to be 6. So that means in order to get this to be 6, I'm going to put a 2 in front of here, because 2 times the 3 gives me 6. Notice that this also changed the iron though, so now I have 2 irons on this side. Okay, in order for it to be the 6 on this side, I have to do 3, right? Because 3 times 2 gives me 6. In order for me to get the iron to be 6 here, I'm going to put a 2 in front of here, like so. So they get 2 and 6. Okay, the names of these. So if I was going to write out the names, so you might want to pause it and see if you can do that. But this one would be iron. Because this is one of the boxes where iron is split in 2, and there's an iron up here, and there's an iron down here, for instance, you have to say which kind of iron it is, so I have to be specific, and I have to use Roman numerals to indicate that this is iron 3 chloride. Now, how do I know that it's iron 3? The way that I know that it's iron 3 is by working backwards, right? If it was iron 2 positive and iron 3 positive, we'll write down both those possibilities. If it was iron 2 positive and Cl negative, the formula would look much different, right? It would look like this. It would be FeCl and then a 2 down here. If it's iron 3, the 3 is going to go down here. I get FeCl3. So I can tell that it's this kind of iron and not this kind of iron. So it is iron 3. Okay, when I write out iron just like this, though, as a element, it doesn't have any indication of the charge on it because it is an element that does not have a charge. So it just says iron. This one is chlorine because it does not have a charge on it, and so it is totally got the ending of INE, the ending that you would find on the table of elements. Okay, we're going to try one more. So it's calcium phosphide. So calcium phosphide decomposes. This is a 3, just doesn't look like a 3. So calcium phosphide decomposes. Okay, so it would decompose into 2 elements. So now I want you to find out what the 2 elements are and write them down and see if you can get it to balance. So it should be, you can pause it here if you need to and see if it works, but you should get Ca and P would be P4 because that is one of the things from the diatomic, and it is in 4s. Now see if you can get it to balance. So if you have to, pause the video and see if you can get it to balance. Remember, you could write out your list underneath each side. On the reactant side, there's 3 calciums and there's 2 phosphoruses, right? So that means that I have to get them to be the same. So let's see if I work with the phosphorus first. So if I have 4 here and I have a 2 here, I'm going to change that by putting a 2 in front of here. This 2 makes this 2 times 2, which is 4. It also changes my calcium on this side, though. So now I have 6 calcium. Okay, so to get 6 calcium over here, I'm going to have to put a 6 in front of here, like so. And now it will be balanced. This is called calcium, and this is just called phosphorus. Okay, see if you can go on to the combustion reactions now.